It's okay.
Alright, okay. So untuk the spontaneous presentation, please look at this video and
Sertailah cabaran teleprompter Malaysia Airlines dengan membuat pengumuman selepas mendarat. Jangan lupa tag Malaysia Airlines. Anda telah sedia? Kita mulakan.
Tuan-tuan dan puan-puan, kita telah mendarat di lapangan terbang antarabangsa Kuala Lumpur. Bagi tujuan keselamatan anda, dikehendaki berada di tempat duduk sehingga isyarat pasangkan tali keledar dipadamkan dan pesawat berhenti sepenuhnya. Berhati-hati ketika membuka ruang penyimpanan di atas. Pastikan semua barangan kepunyaan anda telah diambil. Anda dibenarkan memasang telefon bimbit selepas tanda isyarat pasangkan tali keledar dipadamkan. Waktu tempatan 9 pagi hari Isnin 25 Julai dan suhu 28 darjah Celsius. Kepada semua pelawat kami mengucapkan selamat datang ke Malaysia dan kepada warga negara selamat pulang ke tanah air.
yay! Boleh jadi pramugari nampaknya, Syafika.
Malu.
Impressive.
Yeah, okay.
Bidang.
Thank you very much, group number 1. Okay, group lain jangan ketawa sangat, group lain nanti you all pula kena. Alright. Okay, let's move on to group number 2.
Hello, Assalamualaikum and very good evening to everyone. So we are from group number 2. I am Alia Hanani. We have Stella Humphrey and also Anelka. So we are going to present about the guidelines on selecting and using the transducer.
Okay, first, before we select the transducer, we need to have a few characteristics that we should look. Okay, for the first one is range, which is the transducer. The transducer should maintain the range requirement and have a good resolution over its entire range. The rating of the transducer should be sufficient so that it does not break down while working in its specified operating range. For example, we cannot choose a temperature sensing transducer that work in range 0 until 100 degrees Celsius for a use in a boiler where the temperature is up to 1000 degrees Celsius. And secondly, the sensitivity. The transducer must be sensitive enough to produce detectable output. In general, so this is the equation of sensitivity. In general, the sensitivity of transducer is not constant. Based on this formula, sensitivity of transducer is not constant, but it is depend upon the quantity of QI. QI at the back this. Okay, and then loading effect. Loading effect is the transducer should have a high input impedance and low input impedance to avoid loading effect. Next, I will pass to next presenter.
Okay, I'll continue. So the fourth characteristic is about the frequency response. In order of frequency response, it will tell us the measurement of how fast the transducer can respond based on the response time and also the flat frequency response. So as we can see in the picture, before we have the transducer, we will have the power supply first and then the transducer. So the input into the transducer will be generated into this flat frequency response. So whenever the flat frequency response is flat, it is more better to get the in terms of output. So the 5 characteristics is the output format. There are a few types of output of the transducer. First of all is voltage. Next we have current, and then impedance, and also the time function. So we must select the transducer based on the output that we want. And the 6th is the output impedance. So output impedance will tell us or determine the amount of power that can be transferred into the next stage. Because after transducer, we will transfer it into the conditioning circuit. So the output impedance actually cannot be equal to 0, but we have to minimize it into the very, very minimal.
So next is the power requirement. So the power requirement for the transducer is the electrical aspect that need to be consideration, and the length and type of cable required for a transducer. And the error, the transducer should maintain the expected input and output relationship to avoid error in transducer. And last but not least is physical environment. So the transducer need to work under a specified environmental condition and maintains its output and input and output relationship. Also need to able to work in corrosive environment, and last is able to withstand pressure and shock. So I think that's all from us. Thank you.
Okay, thank you, group number 2. So who will be doing the spontaneous presentation?
Alia.
Alia, eh?
Alia.
Okay, Alia. Okay, alright. Okay, for topik tadi tu, apa ni karakteristik for choosing your transducer. Usually in the examination, I will ask you guys to only give like 3 or 4 apa ni karakteristik, taklah semua, but you need to know at least 3 or 4 karakteristik for you to choose a transducer. Okay, so Alia, are you ready, Alia?
Okay.
Okay. Let me share. Okay, kalau Alia saya terpaksa bagi the same teleprompter lah. Okay. Ready?
Sertailah cabaran teleprompter Malaysia Airlines dengan membuat pengumuman selepas mendarat. Jangan lupa tag Malaysia Airlines. Anda telah sedia? Kita
Tuan-tuan dan puan-puan, kita telah mendarat di lapangan terbang antarabangsa Kuala Lumpur. Bagi tujuan keselamatan, anda dikendaki berada di tempat duduk sehingga isyarat pasangkan tali keledar dipadamkan dan pesawat berhenti sepenuhnya. Berhati-hati ketika membuka ruang penyimpanan di atas. Pastikan semua barangan kepunyaan anda telah diambil. Anda dibenarkan memasang telefon bimbit selepas tanda isyarat. Pasangkan tali keledar dipadamkan. Waktu tempatan 9 pagi hari Isnin 20 Julai dan suhu 28 darjah Celsius. Kepada semua pelawat, kami mengucapkan selamat datang ke Malaysia dan kepada warga negara, selamat pulang ke tanah air. Malaysia Airlines in-flight landing announcement.
Okay, yang last tu tak payah baca lah Alia. Alright, thank you Alia for being our flight attendant today. Mohon semua grup lain tengok ya, nanti you all boleh vote grup mana yang akan the best presenter. Okay, we'll proceed to group number 3 for the next topic, guideline for accuracy of our measurement, transducer measurement. Okay, silakan group number 3.
Hello, test. Okay. So we are from group 3. We'll present to you about the guidelines to increase the accuracy of the measurement. So next. So for output transducer, so output transducer is where it takes electrical signals and converts them into another form of energy. And also,
may I know who's speaking? Is it Daniel or Vivian?
Daniel.
Daniel.
Okay, I continue. So, for example of output transducer, back. So, example of output transducer is where the lamp converts electricity to light and motor converts electricity into motion. So next. So we find that that pressure transducer. So it uses 3 calibration, which is potentiometer based calibration, electromagnetic based calibration, and software. For potentiometer based calibration, I don't understand much about potentiometer based calibration, but that for pressure transducer, it just turning the screw, adjust the screw of the low end output or high end output. So for electromagnetic based calibration, this type of calibration where it uses magnet and shunt calibration. Okay, so okay, for software, it so for software, the sensor will connect to the monitoring software where the adjustment should be easy. And yeah, that's pretty much of it. Next. Okay, so this calibration equipment is example of I think it's vibration testing, where it has transducer in it. So it's the so I don't so this equipment I don't pretty know much, but so it uses this process to do the calibration for the vibration testing. Okay, so I pass it to the next presenter.
Okay, and I will present about monitor environmental conditions. Changes in the environmental condition of the transducer should be monitored continuously. Measure data can be corrected to account for any changes of environment. Next, Asli.
So I will explain.
Okay.
So one of example to increase the accuracy of measurement is.
Aku ingat.
So one way to increase the accuracy of measurement is by artificially control the measurement environment. So what we do is we enclose any electrical transducer. Let's say we want. So for example, we enclose the transducer in the temperature control environment, temperature control housing, and isolate the device from external shock and vibration. So this is because we know that transducers are capable to convert any physical properties to electrical signal. So that's all for us.
Doctor, just now, my slide. I want to explain more.
Okay.
Okay, about the accuracy of the transducer, traditional back-to-back calibration can be inaccurate if the sensor under calibration is bigger or heavier than the reference sensors. The error grows with the increase of frequency. To avoid the error, we can update the software implement procedure of the calibration by substitution. Beside correcting the error caused by the sensor mass and size, calibration may, by substitution, eliminated the error caused by the non-linearity of measurement channels and reduce the uncertainty of measurements. That's all, Professor. Thank you.
Okay, thank you, group number 3. Just make sure that you understand what you are presenting, like what Viviana just presented at the last two. In any sama je dalam jawab exam ke, when you do presentation ke, you have to understand what you saying rather than just reading from any sources. Okay. For calibration, mostly there are two types of calibration for you to make your measurement accurate. One is through calibration process of the equipment, and second through controlling the environmental condition of the equipment. Okay. So for the doing the calibration of the equipment, there are many different equipments have different type of calibration process. Contohnya yang macam Daniel show the setup of the calibration for the equipment yang tadi dalam gambar dan slide tu, that is specific for that kind of equipment. So different equipment have different calibration process, and usually it's come with the instruction from the manufacturer. Okay. So in terms of environmental condition pula, sama juga. When you take a measurement, you have to make sure the environmental condition are constant throughout the measurements lah. So that when you take one measurement to another measurement, environmental condition dia tak berubah. Kalau berubah, that will affect the accuracy of your measurement. So make sure you understand what you are discussing and studying, especially when you answer your exam. Okay, group number 3, are you ready already for the third spontaneous presenter? Siapa yang akan present? Boleh tahu?
Daniel Jipin.
Alright, Daniel, you're gonna be a pilot today.
Okay.
Ni panjang sangat dia punya intro ni, pilot ni. Saya ke depan sikit. Okay.
Pilot's announcement by taking part in our teleprompter challenge. Remember, tag us at Malaysia Airlines. Are you ready? Go.
Very good morning, ladies and gentlemen, boys and girls. Once again, welcome on board Malaysia Airlines flight from Kuala Lumpur to Kota Kinabalu. My name is Daniel, your pilot. For your information, we are currently cruising at 3 feet above sea level, maintaining an average. This flight will take us approximately 1 hour. The weather en route is estimated to be generally fine, and the weather is reported to be fine as well. Sunny skies of 31 degrees Celsius, subject to air traffic control. We expect to touch down in KLIA at 12:05. In the meantime, sit back, relax, and enjoy your flight.
Thank you, Mr. Pilot. Today, Daniel, cepat kan dia punya teleprompter. Okay, thank you. Okay, let's move on to group number 4.
I will share the slide.
Dengan bunyi ayam tu, Hasanah. Are you at home?
Yes.
Sorry.
Okay, can you see my slide?
Yes.
Slide. Okay. Hi, Assalamualaikum everyone. My group will present about linear variable differential transformer. My name is Hasanah binti Johari. I will present with my friends Ahmad Dufi and Robert Ladin. So what is LVDT? So LVDT is a device that produces an electrical signal that is linearly proportional to mechanical displacement. So it is suitable for application where the displacement are too large for strain gauge to handle. For example, if we have to change from micro inch to inch. So how LVDT sense displacement. So an LVDT measure displacement by associating a specific signal value for any given position of the core. So this association of a signal value to a position occurs through electromagnetic coupling of an AC excitation signal on the primary winding to the core and back to the secondary winding. So the position of the core determines how tightly the signal of the primary coil is coupled to each of the secondary coils. So the two secondary coils are series opposed, which means one in series, but in opposite direction. So this result in the torque signal on each secondary being 180 degrees out of phase. So therefore, phase of this output signal determine direction on and its amplitude and distance. So I think it's a little bit confusing and hard to understand. So I will share a short video. And I'm sorry about the background sound. Just wait, I will share a video.
We enjoy the sound of the kampung. At least student yang tak boleh balik kampung kan? Okay.
Okay, I will set the video.
Dia ada suara ke Hasanah?
Ya. Tak dengar.
There's no sound here.
Oh, lama.
Kena share audio dekat share screen tadi.
Dekat share screen. Doktor ke yang kena share ke saya ke?
Hasanah rasanya. Masa share screen tu, you have to share the audio.
Kejap, ya.
Okay, you semula.
Okay, share sama. Nak start balik ke?
Semula lah. I think the explanation is important.
Okay, kejap ya.
How they work. An LVDT consists of a hollow metal
Okay, thank you.
cylinder with a shaft or push rod that moves freely back and forth inside the cylinder. The push rod is connected to a magnetically conductive core. A primary coil is wrapped around the middle of the cylinder and is energized by a constant amplitude AC source known as primary excitation, while two secondary coils having equal number of turns are wrapped around either side of the cylinder at equal distances from the primary coil. The two secondary coils are connected in series, generating an AC output voltage. With the core at dead center, no voltage appears at the secondary output. But as soon as the core moves, by even the smallest amount, a differential voltage is induced at the secondary output. The phase of the voltage is determined by the direction of the core's displacement, while the amplitude is determined more or less linearly by the magnitude of the core's movement from the center. Signal conditioning is required to convert the analog AC output to either 5 volts DC, 4 to 20 milliamps, or whichever format is compatible with your data acquisition system. This differential design gives the LVDT significant advantage over potentiometer-type devices. In an LVDT, any movement of the core causes the proportional change in output, giving it infinite resolution, limited only by the external output electronics. Still have questions? We have answers. Call or chat online at omega.com.
Okay, that's all. So I will ask Lutfi to continue our presentation. Okay, how do I switch? Okay.
Hello. Okay. Okay. Thank you, Asana. So my name is Robert Jenaremong. So I will be presenting on the sensitivity of an LVDT. So first is voltage output voltage, which is sensitivity. So sensitivity must be specific, and sensitivity can be specified by the output per thousands of an inch core displacement, which is via voltage input. The gain required of the signal conditioning electronic is mainly affected by sensitivity. So there is the formula to find the VO in this LVDT, which is output voltage divided by the displacement, which is voltage input. And the sensitivity is mostly affected by the gain required of the LVDT signal conditioning electronic. And when there is a high input, there will be high sensitivity as well. So when it's high sensitivity, it doesn't need any amplification. So for the displacement, LVDT measure this displacement by associating a specific signal value for any given position of the core, and this association of a signal volume to a position occurs through electromagnetic coupling of an AC excitation signal on the primary winding to the core and back to the secondary windings. So in voltage input in displacement, it's which is linear displacement. It needs around 3 to 4 connection wire for power supply, and it have one primary and 2 secondary coil, one primary coil and 2 secondary coils, and this LVDT is known as one of the most reliable sensors out there. So I think it's all for me. Thank you.
Okay, thank you, Daniel. Robert. So Lutfi will present the third. Lutfi. Okay, Lutfi, are you going to become a stewardess or to become a pilot?
Doctor, actually I have one simple explanation on the linearity of LVDT.
Okay, all right, go ahead.
Okay, so I'm gonna explain about the linearity of the LVDT. Okay. So before that, you need to understand what is means of the linearity, which is linearity is a behavior of circuit in which the output signal strength directly proportional to input signal strength. This okay, this means if the input signal, which is let's say around 0.5, in which the output signal also will be produced around 0.5, something like that. So it is but if the input signal are really high, it will affect the output signal strength also. It will change a little bit. I'm sorry, I'm not really understand about that. Okay, so I'm not sure about the name. Okay, so this is the graph based on the displacement and also the output voltage being produced. Okay, so this if you can see from the video that Hasana already shown to us, if it at the center, it will produce zero voltage, Then if we move to the right hand side, it will produce what we call that produce voltage, and also but for the both side, if either it go right side or left side, it will produce a same amount of voltage. It will not be different. Okay. So that's all for me. That's all for my group about things. Thank you.
Okay, thank you, Lutfi. So the main points that you need to understand about LDVT is that LDVT ni sebenarnya transducer untuk mengukur displacement. Okay, so it usually occur in many machineries, I guess, when not really biological and biosystem punya application, but mostly on machinery. So if you learn your machinery design class, this kind of this kind of transducer is very useful. Okay, so this so if you can see the video that has been shown just now, it based on the movement of the core at the center of the rod. Okay, and then when you put current, when you put current and you have movement, it will generate electromagnetic field. So bila dia generate electromagnetic field, the voltage that we measure through it is proportional to the displacement. Okay, so that's why it called linear displacement transducer, linear. Okay, so the displacement will be linearly correlated with the amount of voltage that has been produced. So and then two things that you need to remember, there are two parameters that characteristic of LDVT. One is the sensitivity and one is the displacement. Okay, sensitivity is based on the signal conditioning and also the converted signal from the displacement. Okay, so only those things that you need to capture lah from this topic. Okay, ready? Siapa yang akan buat the third presentation tu? Robert or Lutfi or Hassan?
Lutfi.
Saya kata.
Lutfi, okay. So Lutfi, I give you a preference. You want to become a stewardess or you want to become a pilot?
Pilot kata.
Pilot, right. That's a gentleman. Let's hear pilot Lutfi today. Sekejap, Okay, ready?
Pilot's announcement by taking part in our teleprompter challenge. Remember, taggers at Malaysia Airlines. Are you ready? Go.
A very good morning, ladies and gentlemen, boys and girls. Once again, welcome on board Malaysia Airlines flight from Kuala Lumpur to Kedah. My name is Ahmad Lutfi from your pilot. For your information, we are currently cruising at 39,000 feet level and maintaining a operational speed of 950 km per hour. This flight will take approximately 1 hour. The weather en route is estimated to be generally fine, and the weather in Kedah is reported being fine as well. Sun sky, average ground surface temperature of 31 degrees Celsius. Subject to air traffic control, we expect to touch down in Kedah Airport in 15 minutes past 12. In the meantime, sit back, relax, and enjoy your flight.
Alright, thank you Pilot Lutfi. Pilot Lutfi ni mengantuk Pilot Lutfi. Okay, thank you very much. Okay, we go further to group number 5.
Okay, I will share the screen. Okay, did everyone see my screen?
Yes.
Yes.
Alright. So, Assalamualaikum warahmatullahi wabarakatuh and a very good evening, everyone. So, our topic for today is turbine flow meter. So basically, turbine flow meter, when we see the name also, we can see that this turbine flow meter is for volumetric total flow or flow rate measurement, and has a relative simple working principle. So basically, it's to measure the volumetric total or the flow rate measurement. So this is the component in the turbine flow meter, which the important that I want to highlight here is the rim type rotor assembly, because the rotor will be pushing, and then it will show the flow rate. So I want to share this video. Everyone see the video, but I will not share the sound because I want to explain it. Okay. Basically, in this turbine flow meter, wait, I want to show. Okay, this one. Okay, under the inside the turbine flow meter, there's a rotor here, and the higher the flow rate, the higher the rotor will spin, and then this is the pickup point, which will generate the pulse that we can count as the flow rate. Yes, like that. And what we can see here, this is the uniform square wave pulses, which there are two type of pulses that will generate from the rotor, which is AC type output, which consists of 2-wire passive magnetic pickup sensor, and for the uniform square wave pulses, which is this one, use 3-wire active Hall effect sensor. All right. So okay. If we buy the turbine flow meter, it will come with the K factor, which indicate the like this one. It's indicate 150 pulse per gallon, which means that the flow rate will count using this pulse. Okay. Okay, this is it. The pulse showed that 150 pulses per gallon. This is the gallon of water that flow in the turbine flow meter. Okay, I will give the presentation to Jeffiana.
Okay. Can everyone see my slide?
Yes.
So how about this one? Is it clear enough?
Yes.
Okay. So my name is Nurjafina binti Laobi, and I will present the application of turbine flow meter. So this is one of the examples which industries applied this turbine flow meter, which are oil and gas, power generation, and aerospace. So one of the example in oil and gas field are water injection and chemical injection. However, for the aerospace, the turbine flow meter is applied at the engine testing and fluid flow measurement. So this is the examples of turbine flow meter. So this is the example in oil and gas industry, and this is the example for in the industrial field. So I'll pass the next presentation to Lukman.
Okay. Assalamualaikum and everyone. So I will explain to you about the advantage and the disadvantage of turbine flow meter. I will make it short and simple. So for the first one, the first advantage is it is suitable for gases and liquids. So basically, as I think Azad already explained about it. I think actually there is two types of turbine flow meter, which is first gases turbine flow meter, and next is the liquid turbine flow meter. So this turbine flow meter is suitable for these two types of condition, which is gas and liquid. So the next one, it is highly accurate and precise. So the typical accuracy
and repeatability of the turbine flow meter actually are plus minus 0.5% and plus minus 0.1% respectively, which is the 0.5% for accuracy and 0.1% is the precise or repeatability. So however, it is possible to achieve the accuracy of smaller than 0.5 and 0.1. So the third one, the advantage is easy to set up and operate. So as you can see at the picture above, it is shown a turbine flow meter. So the next one is the disadvantage. First, requirement of clean, dry liquid gas and sample. It is because the incompatible fluid, which is not suitable fluid, will deteriorate or will damage the internal parts of the turbine flow meter, and it will cause the inaccurate reading. So next is the errors caused by high viscosity in samples. It is because there is some air or gas in the fluids, so it will cause the viscosity to sometimes higher than the calibration itself, calibration fluid viscosity itself. So the last disadvantage is the frequent calibration checks needed. So sometimes the flow meter will will face the vibration during the process. So the severe vibration may decrease the life of the flow meter itself. So there is some advantage and disadvantage of this turbine flow meter. So that's why we have another two types of flow meter which will be presented by next group. So I think that is from us.
Okay, thank you very much, group number 5. I think the explanation is very clear, and the principle of the measurement also not very much different from the LDVT actually. If you see this one, kalau LDVT is based on the core rod punya movement or displacement, but in this case for turbine flow meter, it's based on the liquid that is flowing inside of the tube. So principle wise is the same. Okay, and then the fluid will rotate the transducer, and then the signal will be converted and counted electronically. Okay, so hopefully all of you pay attention to your friend's presentation. So for group number 5, who will be the spontaneous presenter today?
Luqman. Luqman will be the pilot for today.
Yeah, Luqman. Okay, so we have pilot Luqman.
Yes, Doktor.
Alright, kejap mana dia tadi video. I have to share back the video. Pilot punya video dah hilang. Sorry. Saya ada video stewardess je. Takkan nak suruh Luqman jadi stewardess kan? Cancel this one. Alright. Okay, ready?
Edition of a pilot's announcement by taking part in our teleprompter challenge. Remember, tag us at Malaysia Airlines. Are you ready? Go.
A very good morning, ladies and gentlemen, boys and girls. Once again, welcome on board Malaysia Airlines flight from Kuala Lumpur to Johor Bahru. My name is Luqman, the pilot. For your information, we are currently cruising at 39,000 feet above sea level, maintaining an average ground speed of about 950 km per hour. This flight will take us approximately 3 hours. The weather en route is estimated to be, and the weather is fine. It's reported to be fine as well. Sun skies and the average ground surface temperature of 31 degrees Celsius. Subject to air traffic control, we expect to touch down in Senai Airport at 5 minutes past 12. In the meantime, sit back, relax, and enjoy your flight.
Wow. Alright, congratulations, pilot Luqman. So we are now arriving Johor Bahru. Tadi Kedah dah merata dah kelas kita pergi petang ni. Okay, thank you very much. We proceed to group number 6 for magnetic flow meter presentation.
Okay, Assalamualaikum and very good afternoon to everyone. So we're from group number 6. We'll be presenting about magnetic flow meter. So what is a magnetic flow meter? So a magnetic flow meter is a transducer used to measure the flow of electrically conductive fluid. So this magnetic flow meter is ideal for wastewater applications or any dirty liquid which is conductive or water-based, and also ideal for low pressure applications. This magnetic flow meter does not contain any moving parts in it, as you all can see in the picture. The only moving part in the magnetic flow meter will be the magnetic field, but we cannot see the magnetic field. So this magnetic flow meter also will not work with hydrocarbon and distilled water, since this transducer is only used to measure the flow of electrically conductive fluid. So the hydrocarbon and distilled water is not conductive fluid. So generally, it will not work with non-aqueous solution. And this magnetic flow is also low maintenance. So for the working principle, I will proceed with the next presenter. Thank you.
Okay, I will present the working principle or how it works. Magnetic flow meters use a magnetic field to generate and channel liquid flow through a pipe. Second, a voltage signal is created when a conductive liquid flows through the flow meter's magnetic field. The faster the flow of the fluid, the greater the voltage signal generated. Electrode sensor located on the flow tube wall picks up the voltage signals and send it to the electronic transmitter, which process the signal to determine liquid flow. Okay, next. Okay, the operation of a magnetic flow meter or magmeter is based on Faraday law, which state that the voltage induced across any conductor as it moves at right angle through the magnetic field is proportional to the velocity of the conductor. The law states that E is equal to B divided by V. In electromagnetic flow meter, the conductor is the liquid flowing through the pipe. E is equal to B multiply D multiply V. Okay, so next presenter, Fahmi.
Assalamualaikum warahmatullahi wabarakatuh. I would like to present about advantage using a electromagnetic flow meter. First advantage is the electromagnetic flow meter provide rapid response to flow change. Second is provide linear wide range. Third, measuring range setting can be optimized. Fourth, it has ability to measure river flow. And the last is no additional pressure drops. It is unaffected by change in temperature, density, viscosity, concentration, and electrical conductivity. Okay, thank you.
Thank you very much. Group number 6, is it all for
Yes, Doctor. This is all from us.
Thank you very much about magnetic flow. Okay, principle was similar to the previous one, but this one the fluid has to be a conductor, right? The fluid of the magnetic flow meter. And also the application of this kind of flow meter macam sama juga tadi, turbine is more for oil and gas and also irrigation lah. If you relate to your program or biosystem engineering, it will related to irrigation punya application. You guys learn irrigation and drainage. I think further in your course you will take irrigation and drainage punya class later. Okay, for group number 6, who will become the teleprompter reader?
Me, Doctor.
Daniel. So Daniel, of
Yes.
course, Daniel kena jadi pilot kan?
Betul.
Mana nak jadi pilot Sekejap Masa kecil-kecil je cerita nak jadi apa? Ada tak jadi pilot?
Betul, Doctor. Saya memang cita-cita nak jadi pilot dulu.
Wow, okay. Let's give a chance for Daniel to become a pilot today. Ready?
Of a pilot's announcement by taking part in our teleprompter challenge. Remember, tag us at Malaysia Airlines. Are you ready? Go.
A very good morning, ladies and gentlemen, boys and girls. Once again, welcome on board Malaysia Airlines flight from Kuala Lumpur to Penang. My name is Daniel Haziq, the pilot. For your information, we are currently cruising at 39,000 feet above sea level, maintaining at an average ground speed of about 950 kilometers per hour. This flight will take us approximately 3 hours per minute. The weather en route is estimated to be generally fine. Weather is and an average ground surface temperature of 31 degrees Celsius. Subject to air traffic control, we expect to touch down in Penang International Airport 5 minutes past 12. In the meantime, sit back, relax, and enjoy your flight. Thank you.
Yeah, thank you, Pilot Daniel. Alhamdulillah, today in a few minutes we arrive Penang.
Betul.
Okay, let's proceed to group number 7. Hot wire anemometer, yeah.
Assalamualaikum. Can you hear me?
Yes, loud and clear.
Okay. Assalamualaikum. I am Najiha from group 7 and my group mates are Mustaqim and Amir. So our group will present on hot wire anemometer. Hot wire anemometer is a device used to measure the velocities and direction of the fluid. The use of hot wire will allow instantaneous flow velocity to be calculated from electric voltage measurement. This means if a cooler fluid flows past the wire, heat is removed from it. Okay, next. The hot wire anemometer consists of two main parts, which is conducting wire and Wheatstone bridge. The conducting wire is housed inside the ceramic body. The wires are taken out from the ceramic body and connecting to the Wheatstone bridge. The Wheatstone bridge measures the variation of resistance. Next, I pass to Amir.
Okay, thank you to Nadia for the introduction. So I will continue with the application of hot wire anemometer. So firstly, it used to monitor the air intake of an engine. So the automotive engineers, they use the advance of the hot wire anemometer, which is grid style hot wire, to monitor the air intake of engine. By doing that, they develop cabin comfort and climate control system in engine. So the second one, it used to measure airflow, temperature, and humidity on components, such as computer chips on computer. So as you can see on the picture below, there are three data that we measure inside the computer. And the last one, it is used to monitor airflow in biosafety cabinets, chemical fume hoods, and laminar flow hoods. It is in the pharmaceutical and laboratory environment, which by doing the hot wire anemometer, it is a method of safety and compliance with regulation design, so it will protect the workers who work there. So I think that's all from us. Thank you.
All right, thank you very much. So Mustaqim will be the pilot ke?
Yes.
Yes.
So, ramai pilot lah hari ni. Okay, thank you very much group number 7 for the hot wire anemometer. So for hot wire anemometer, the purpose is for for you to measure the viscosity, air pressure dan sebagainya. And the application is more towards machinery ataupun system lah. Okay. Okay, so without further ado, we'll invite pilot Mustaqim. So hari ni pilot Mustaqim nak bawa kita pergi mana ni?
So yeah, I'll start.
Oi, ramai nak pergi Al-Ustaz je ni. Ramai nak pergi Kedah ni. Okey, sekejap Ready Mustaqim?
Of a pilot's announcement by taking part in our teleprompter challenge. Remember, tag us at Malaysia Airlines. Are you ready? Go.
A very good morning, ladies and gentlemen, boys and girls. Once again, welcome on board Malaysian Airlines flight from Kuala Lumpur to Al-Ustaz Kedah. My name is Mustaqim, your pilot. For your information, we are currently cruising at 39,000 feet above sea level, maintaining an average ground speed of about 950 km per hour. This flight will take us approximately 1 hour. The weather of an hour is estimated to be weather and destination is reportedly to be fine as well. Sunny, laju ya, temperature and 39 degrees Celsius. Subject to air traffic control, we are expected to touch down in airport. In the meantime, sit back, relax, and enjoy your flight. Thank you.
All right, thank you. We all enjoying the flight, Pilot Mustaqim. Thank you very much. We arriving Al-Ustaz sekarang. All right, so that will be the end of the presentation from each of the group. Betul ke? Dah tak ada kan? Tinggal lagi slide tu, ada a few more slides that I will finish and then for the time being, you also need to vote for your best group presentation. Okay? Ada kan link dekat dalam chat box tu? Okay, saya teruskan kepada what is the differences between sensors and transducer. Okay, so usually in your examination, there will be questions like describe the differences between a sensor and a transducer, and then give an example of transducer that incorporates a displacement sensor, and give another example of a sensor that is also a transducer. Okay, selalunya soalan-soalan macam itulah yang akan ditanya dalam examination. So let's see what is the difference between transducer and sensor. So transducer is a device that converts energy from one form to another. Tadi rasanya ada kawan, your friend, one of your member dah bagi tahu what is a transducer. So transducer ni adalah alat yang mengubah signal daripada satu energi kepada energi yang lain. So kalau ada involve a transformation of energy, we call it transducer. Okay, while sensor is a device module or subsystem who's supposed to detect event or changes in its environment and then send the information to their electronics, frequently or a computer processor. Okay, kalau kita tengok perbandingan di antara transducer and sensor, we can see this, the sensor is actually a part of a transducer. So transducer bila consists of sensor, signal conditioning, and you have an input signal and you have an output signal, itu dipanggil sebagai transducer. So kalau lihat gambar raja ni, you will easily more understand about what is sensor and what is transducer. So kalau kita tengok dari segi definition, sensor sense the physical changes occur in the surrounding and converting it into a readable quantity. Maksudnya dia akan tukarkan signal tu kepada quantity yang boleh dibaca, di-measure. Yang kita banyak belajar all this while kita buat sensor kan, kita detect the changes of the resistance and convert into electrical measurement. Tapi tak semestinya kita convert energy. But when you the transformation involve energy from one form to another, then we call it as transducer. Okay, so the components for sensor, usually the sensor itself, but for transducer, the component for transducer involves sensors and signal conditioning. Okay, the function for sensor detects the changes and induce the corresponding electric signal. And the function for transducer is the conversion of one energy to another. Okay, so that is clear lah, dah banyak kali kita beritahu. Okay, example of sensors and transducer, contoh-contoh yang kita dah belajar dalam lab, we have a light sensor, temperature sensor. Okay, temperature sensor, thermistor, thermocouple kebanyakannya adalah dalam group transducer sebab dia melibatkan signal conditioning. Okay, so hopefully you guys clear about the differences between sensor and transducer. And I think it's pretty straightforward juga. And you have to remember this diagram. I think it will be easier for you to remember. Sensor is actually part of transducer. Ada juga sensor yang juga sebab tu banyak sensor kita panggil juga transducer sebab it serve similar purposes. Okay, that will be the end of my lecture today. I would like to see, kita tengok siapa pemenang presenter kita hari ini. Sekejap saya check the Google Form. Semua dah vote?
Dah.
Macam ada 12 je respon ni. You all ada berapa orang? Ramai kan? Sekejap. Saya tengok respons ada 13. Masih ada yang belum apa ni? Belum jawab. Mohon semua jawab. The vote for your group. The best presentation award goes to what group? Tapi jangan vote group sendiri ya. Please be honest on that. Okay, 16 orang. Lagi berapa orang ni? Okay, 18 orang baru. Okay, the most spontaneous presenter was from group mana? Okay, 18 orang. Sekejap, kita tengok berapa orang ada dalam kelas kita hari ni. Mana dia dah hilang? 20 orang. Ada lagi 2 ni tak vote ni. Okay ke? Ada lagi tak yang nak vote? Kalau tak saya akan buka responses ni. So, pilot Luffy berharap dia dapat menjadi pilot yang sebenar hari ni. Okey, nampaknya macam dah tak ada dah. Okey, saya akan lihat siapakah yang mendapat vote tertinggi. Uish, agak diverse juga Sekejap Grup tertinggi adalah, susah ni saya nak bagi tahu ni, ada banyak sangat ni. Sekejap nak kena kira. Let me see. Summary, macam mana saya nak tengok responses ni. Okay, grup warna darah 16.2. Oh, ada seri. Tak. Okay, alright. Dah ada finalis kita. Nampaknya pemenang adalah bukanlah di kalangan pilot. Alah, kecewa dah. Pilot Luffy dah kecewa. Pemenangnya adalah daripada grup nombor 1. So tanya kepada siapa pramugari siapa tadi? Yang grup nombor 1 siapa?
Syafika.
Syafika.
Saya doktor.
Dari Malaysia Airlines kita pada hari ini. Thank you very much. So nanti Syafika tolong WhatsAppkan your address to get a surprise for your group lah bukan seseorang tau, for your group.
Okay, doktor.
Saya akan bagi sedikit token of appreciation from me for your group. So that will be the end of our class today. Thank you very much semua kerana memberikan komitmen dan bekerjasama untuk menghabiskan juga kan satu semester kelas EAB 3612. Boleh ke saya mohon semua kalau boleh turn on your camera for us to have a group photo for our class today. Sebelum tu kan saya nak share lah ke you all dah tengok dah kan yang teleprompter punya challenge, the real the real pramugari yang baca kan. Tak payahlah tunjuk Okay, semua dah pasang? Say kimchi. Sekejap, next page. Oh, ada satu page you all semua? Okay. Azlan habis dah betulkan rambut. Okay, semula. Say kimchi. Alright, thank you very much everyone. Saya ucapkan all the best for you for the rest of the week of the semester. And for your final exam. For your final exam nanti mungkin saya akan bagi tips lah for your final exam, sebab tapi soalan pun saya dan Dr. Diana pun belum buat lagi. Jadi once dah closer to your examination, tahu tak tarikh you all punya exam 16 Julai kan? Hari Jumaat pukul 2.30 ke 3.30?
3.30.
Okay. So remember July 16 it will be virtual exam, dan saya akan bagi tips for your examination lah. So all the best, and for your class assignment semua project, saya rasa end of the week ni kan you all akan deadline untuk hantar semua. Saya akan cuba mark before week 15 end, so that you will see your carry marks, and siapa yang ada carry marks agak rendah kita akan cuba bantu dari segi your I don't know how maybe perbaiki your report of your project ke ataupun your report of your assignment. Saya akan cuba bantu. Okay, so that you will get a better mark and you learn to improve yourself lah in your class. Okay, so with that all the best everyone, and jumpa lagi insyaAllah waktu final exam. Okay. Bye. Thank you.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.